So I'm here today with Johann. Johann is joining us from QAN Platform. We've been talking about quantum computing a little bit in disruption banking as well recently. A few weeks ago, we gave an article out about quantum working. And we also were looking recently at Google's quantum supremacy moment. But without further ado, I wanted to ask Johann a few words about what's happening in QAN Platform. First of all, how do I pronounce that, Johann?
It's QAN. Hi everybody, it's Johann Polecsak here. So it's pronounced QAN Platform.
Okay, lovely. And one of the things we've noticed about your platform is that obviously you have a very big opinion on Ethereum. We had huge expectations from Ethereum here at Disruption Banking. Everyone was talking about smart contracts, the future. Yeah. It looked like really the next big thing. Let's not talk about the price of Ethereum though, because that hurts. I think a lot of people are hurt by that. But how did you come up with the concept that perhaps you're starting to consider that Ethereum is an older platform now? And how have you taken that and built onto the new ideas that you've got?
You know, it's a very interesting question in my opinion, because what we can see that there are already, so if we leave just for a moment QAN Platform alone, and if we take a look at the market, there are already solutions much better from a technical standpoint of view than Ethereum is. But still, Ethereum is the most widespread one. And the answer to the question why is very easy, because they have the biggest coverage regarding documentation, they have the biggest community. So if you want to launch your own private blockchain network, or you want to start coding away some smart contract, the most resources you will find is those for Ethereum. And this is what's really important, because we see that there are many new blockchain startups creating new blockchains and stuff. And you know, if you don't put proper focus on the ease of use, how easily I can try it out, right? Because there is also the platform called Parity Substrate, which the guys created from Parity. So Parity created an Ethereum client in Rust back then, and now they launched their own blockchain network as well. And you know, I looked deep into it, I did some speed tests, and you know, to be honest, it was a nightmare. I don't want to bash these guys, and obviously it's not easy to put something properly together, but there were promises also like 100,000 transactions per second, which turned out to be 64. And things like this, you know, and the documentation is not always helping. And I know very well that it's easy to criticize something and it's very hard to do something right on the other hand, but I can promise that QAN Platform will put a huge focus on this to make it as easy as possible to adopt and to try it out. Because me, myself, I have so little time, because people who are really into IT and have you know, tight schedules, they are not going to waste a single minute. So if I can try out something within 1 or 2 hours, I'm going to leave it alone. Maybe during the holidays if it's really interesting to me. But I think 1 or 2 hours is the absolute maximum for a developer to just try something out. You know, whether it works or not, how it looks like, and just get started with something.
But Johann, just for the interest of our viewers. With Bitcoin, we know that Bitcoin mining improves the hash rate. With Ethereum, how do you improve the hash rate? You can't mine it, can you? How do you do that? And with your platform, surely you have to also have a hell of a lot of servers somewhere in some cold room.
No, I don't really understand the question maybe, but what you mean that if you mine Bitcoin there, you are going to improve the hash rate? You mean the more people mine it,
all the blocks have to click in, yeah? And the blocks clicking in happen because the servers are going in the background and the mining is taking place, and that improves the... Is that not the same in your case?
For QAN Platform, no. So from this standpoint of view, Bitcoin and Ethereum are fairly similar, because they are both using proof of work. Now Ethereum started rolling out Ethereum 2.0, which will migrate to proof of stake, but still, so what we know as Ethereum until now, they are very similar. They both use proof of work, which is just what you explained, the hash rate and the difficulty, and the blocks must click together. And well, in our case, no, it's completely different. So as for proof of randomness, it's a totally new kind of beast. Yeah, where should I start? So maybe let's start just with a brief background, because this is widespread information already related to proof of work. We all know that there are these mining machines and they do some kind of computation, and whoever solves this formula gets to be the lucky one who can append the next block to the chain and gets a reward for this. Right. So what's good in this and what's bad? What's good is that it's completely democratic. So you can buy your own mining machine and you have the same chance as winning as anybody else. I mean, obviously in proportion to the amount you invested in mining machines. So the same amount of dollars spent on mining rigs gets you the same advantage or same chances against other players on the market. What's bad about it, so we can say that it's democratic. So this is the benefit, democracy. What's bad about it is the enormous energy consumption, as we all know. So I don't know if you heard, but from just a single Bitcoin transaction, so let's say I wire you $50 in Bitcoin, you could power the average US household for more than 20 days, which is just ridiculous. Also on Ethereum, the number is just a bit lower, but still enormous. From one Ethereum transaction, you could do like a 200-kilometer drive with an electric car, which is just, we can see that this is not going to work in the long run. So something called proof of stake was born, which was set to eliminate this problem. And well, it kind of does, but on the other hand, it's not democratic. So it reduces the energy consumption by a great deal. But on the other hand, you would have the first mover advantage, because proof of stake works like you stake your coins or tokens and you vote on the block validity with your tokens. So basically people with more wealth will immediately can execute higher chances, and well, this is something which is often criticized. Although if you try to cheat, you will lose your stake. So there are certain mechanisms in the background to prevent malicious use cases. But yes, certainly not as democratic as proof of work. So these are the two edges which we are competing with. So you are either fully democratic or you are using a lot of energy, and this is what proof of randomness solves, because this way you can remain fully democratic and consume almost as little energy as proof of stake. So we solve this puzzle with this. Without going too deep technical, you can imagine it like there are participants who are willing to mine, and I'm saying not mining because mining is using lots of energy, which we don't do. But let's say there are a group of people who want to participate in appending the next block to the chain, and they have virtual hat, and everybody writes down some random number, which doesn't have to be random, but let's say they write down a random number, throw it into the hat, and we can deterministically calculate the winner based on the contents of the hat.
Okay.
You know, so no need to guess billions of random numbers as with proof of work, but everybody puts their one number, throws it into the pool, and we can pick the random winner based on the contents of the hat. So it's not picked randomly, but it's picked deterministically, which is the most important, because all parties can agree that yes, he is the chosen one because this is the formula. So in a nutshell, this is how it works. And what's more important, what I just said, that it solves both issues, so the energy consumption and the democracy of sustaining the network.
It's good that you're considering that area. Obviously, there are a lot of people involved in the crypto market. I think when we got involved, there was something like 100,000 people involved in crypto globally. Today, what do you think? Maybe 300,000-400,000 people in that market?
That's really tough to say, to be honest. I don't follow the market itself that much, especially not the cryptocurrency prices, but I'm much more into technology. And from that perspective, I can tell you that there's no better solution that we are aware of to tackle both these issues at the same time.
Okay, so America is obviously leading a lot of these things, and as we pointed out, I think last November, October, Google suggests that they have reached quantum supremacy.
Yes.
Now, for our readers who maybe didn't read past that comment in our article a few weeks ago, perhaps you can explain how you see quantum supremacy and how that links into all of this.
So, quantum computing and Google's quantum supremacy. Yes, it's an interesting topic, and you will find tons of articles. I won't explain it deeply, what you can already find there. But the thing is that they managed to solve a formula which would have taken traditional computers a magnitude of time, and they managed to do it within a couple of seconds. I don't know the exact time frames, but I think more 1,000 years versus seconds, so it's a significant leap. But this is not the key point. But the key point is that now people can see that those attacks, which were already known that they would exist and would be executable sometime, now those were theories, and now we are here in practice. So these kind of attacks get proven in practice day by day now. So as quantum computing capacities start to increase, from IBM, you can already rent quantum computers to start experimenting. And the main issue is, I wrote a great article about this, by the way, which I can send to you, because many fail to grasp the importance of this problem, because most of the CTOs, and to be completely honest, I was one of these kind of CTOs 1 year before, completely neglect the issue that well, I'm surely not the one to solve this quantum computing problem. Someone up there must be working on this. And surely when I will see the headlines that quantum computing is breaking today's encryption standards, then I'm going to just migrate to a quantum-resistant encryption stack, which seems to make sense, except that it doesn't, like at all. Because it's fairly easy to listen to traffic between two endpoints. I mean, let's say you are communicating with your internet banking software, whatever, and I can easily monitor the network traffic between your machine and the internet banking server. The only issue is that your connection is encrypted, and I can't read what's going back and forth between you and the other endpoint. But if I start recording this traffic, and quantum computing will become mainstream and publicly accessible, I can read everything you did back then. So, and there are many, many time-sensitive businesses, not to speak of governments, military, you name it, whose flow of information is really time-sensitive. So it would pose a great risk to them that their today's communications could be read 3, 5, 10 years later. So this is why the simple analogy that once I see the headlines that we have the problem, then I will just switch to another encryption standard, because you might have already failed at that time and you can do nothing to cover your past.
So in that respect, QAN Platform could be both something that hackers could learn from, as well as something you could probably sell to exchanges, stock exchanges, banks, and other companies. Yeah?
Yes.
There's also people who could copy you, yeah?
Yes, exactly. And for this reason, actually, we separated the quantum encryption stack from the platform itself. So, I mean, QAN Platform will still be quantum resistant. It's a built-in function and functionality. But we also created something called QANfence, which is a separate standalone product. So QANfence, which is just solely for encryption, just for wrapping RSA and elliptic curve encryption, which is already proven to be vulnerable to quantum computing, and wrap it into another layer of quantum resistant encryption. So if you are running voice over IP servers or just regular web servers, whatever, so we can integrate it at the TLS level, which is called transport layer security, which like the whole internet backbone relies on. So this is the standard, how to have secure point-to-point communication. And we, it's very hard, because if you have nothing to lose, it's easy to, let's ditch RSA and implement something which is proven mathematically that it's quantum secure. But if you have something to lose, let's say you are a big bank or someone who cannot afford the risk that if tomorrow it turns out that the quantum guys are wrong, and they don't even have the protection of RSA anymore. For those, we worked out a solution that you can wrap RSA into quantum resistant encryption. So you already, I don't know if you can imagine how it looks like, but let's say you have the plain text communication. You encrypt that like you do today with RSA, and the cipher text, so the secure text output by RSA encryption, you wrap it again into something which is quantum resistant. So now the attacker has to breach through 2 layers of security, where the first layer is quantum secure and the second layer is now today's standard. So this way, companies have nothing to lose. They are at least as secure as they are today. On the other hand, while I don't want to sound, like one who doesn't trust their own product, I'm just saying that there is one thing which we surely don't have in comparison to RSA and elliptic curve encryption, and that's practical implementation history, which is key in cryptographic systems. But we don't have it because we are right at the start, right? So this is what I always.
So I'm hearing a little bit of cybersecurity as well coming out from what you're saying, but it appears that you haven't chosen Israel to be the place where you're going to be developing your platform further. Although some people might say that they know a lot more about these things. You've chosen
There's something
Estonia.
in the works. That's all I can tell.
But you've chosen Estonia instead as kind of the hub. Tell us a little bit about why your product is coming out of Estonia and what's brought you to Estonia.
Estonia was chosen when we were dedicated to blockchain development, and I mean we still are, but then the whole concept is that we build a quantum secure blockchain. Then we realized that much more or many more people and companies encrypt their data today than how many companies and people use blockchain today. So it makes sense to create also a separate product just for cryptographic security. And so we separated this part, and this is what I'm saying, that yes, there's something in the works. But yes, Estonia made sense for cryptocurrency and blockchain development. And obviously what you are saying related to Israel, it makes sense. It makes a lot of sense for IT security. You are correct, yes.
I was in Estonia, I think it was about a year ago or 2 years ago, and there was an article there that Satoshi Nakamoto could be Estonian. Obviously, could be American, Japanese. We don't know where he's from, but I haven't heard him come from any other European country apart from Estonia. So you might be onto something there.
I don't know. People even said that he's supposed to be Hungarian, but yeah, I heard this.
Nick Szabo, yes, Nick Szabo. They do say that Nick Szabo could be in. That's right. Yeah. Listen, Johann, it's been delightful to hear your thoughts. If our readers do have any more questions, you mentioned the article earlier, so I'm going to ask you to share that with me later so we can share that with our readers. But I wanted to thank you very much for your time today. It's been very enlightening hearing your thoughts, and it sounds like you've come up with some really novel ideas there, and we'll probably be hearing more about you in the future.
Thank you very much, Andrew. Thank you for the interview. I really enjoyed it as well. So yes, let's keep up the good work.
Super. Thank you again. Cheers.
Thank you. Bye-bye. Have a nice day.